Hi students, welcome to the notes on periodic table families and valence electrons. Get out your science notebook and let's get started. As always, I would write the essential question at the top and really try to think about it as you go through the notes. What causes periodic table families to have similar chemical and physical properties? Here's a periodic table, the one that we use in class, with different families based on the different colors you see here. One thing to note, these colors aren't standard, so you might look at a different periodic table and they have different colorings even though the families are the same. Remember, families are groups of elements with similar chemical and physical properties. Now, some of those properties that I want you to know, I'm going to emphasize here a little bit. Let's start with the alkali metals. The alkali metals, that pink group on the far left, are the most reactive metals. Skipping the alkaline earth metals, let's talk about the transition metals as well as the other metals, the ones in red and light blue. These ones, most of them have variable charges. We're going to learn about how each of the elements have standard charges that they become, but these two groups have charges that kind of change. They're variable. Sometimes they're +2, sometimes they're +4, and we'll talk about that later when we talk about ionic and covalent bonding. All right, this orange group, or the orange family right here, these guys are semiconductors. They're the metalloids. Now, this isn't really a property of the nonmetals of this green group here, but I want you to know that to a biologist, these elements are very important. They're very common in living things. Group 17, also known as the halogens, are the most reactive nonmetals. And finally, the last group, group 18, also called the noble gases, they're inert. That means that they're not reactive. So families and their properties relate to valence electrons. Valence electrons are electrons in the highest energy level, and they're responsible for the chemical properties of the elements and their families. We often symbolize these valence electrons using things called electron dot structures. They're also called Lewis dot structures. But if you take a look here, there's a model on the left known as a Bohr model, and we learned how to draw Bohr models in an earlier unit with the different rings and the electrons. Now, valence electrons are just the electrons in the outermost rings. If you look at the Bohr model, they're the electrons that are in purple. So what we do to really emphasize just those electrons is we simplify our model and we just write the symbol. This is silicon, and we put 4 dots around it. Now, if you're wondering where the dots go, think of silicon, the symbol is kind of like a box or a square, and each side of the square has 2 electrons to it. So as long as you put no more than 2 electrons per side, you'll be fine in drawing the electron dot structure. Now, on the periodic table, there is a trend for valence electrons. If you look, each group of elements have the same number of valence electrons. Group number 1 has 1 valence electron. Group number 2 all have 2 valence electrons. Transition metals are a little weird. Most of them have 2 valence electrons, and then their outer shell electrons kind of fall back in. But if we skip all the way to group 13, they have 3, group 14 have 4, group 15 have 5, group 16 has 6, group 17 have 7, and group 18, all of them except for helium have 8. And that's because the first energy level only can hold 2 electrons, and helium only has 2 electrons in that energy level. The last thing I want to talk about is the reactivity trend. So we talked a little bit about valence electrons and how they relate to the families on the periodic table, but reactivity deals with that as well. If you look, the most reactive elements are the alkali metals, the group on the far left, and the halogens, the second to the last group on the far right. The noble gases also relate to this as well. They don't react at all, and it all relates to valence electrons and electronegativity and ionization energy. Remember, electronegativity is a tendency for an atom to attract electrons. And elements in group 1 only have 1 electron. Elements in group 18 or group 17 have 7 valence electrons. So they're the extreme ends on the amount of electrons elements can have. Elements in group 18, the noble gases, don't react because they're full of electrons. They have 8 outer shell electrons, and that's really important. All right, that leads us to the end of our notes. I would take some time right now to review these notes, maybe highlight key terms using a colored pen or a highlighter. Ponder and ask questions. Are you still confused about things? Maybe seek some answers with some external resources. Finally, summarize and answer that essential question. Use your notes to help you do that. All right, good luck.